Hi everyone, welcome back to Coding with Bharat channel. So let's discuss the fourth problem of this week's weekly contest, which was minimize Manhattan distances. So this was a hard problem, a nice problem in my opinion, which dealt with a little bit of geometry, a little bit of maths, and a lot of coding. So let's get started. So it said, let's say we are given an array of points. So any point is in fact equivalent to an x and y coordinate on the 2D plane, right? So we have different points with their x and y coordinates. Now what it says, you can remove exactly one point. So yeah, basically you are allowed to remove exactly one point, and they said that distance between any two points is defined as the Manhattan distance between them. So what is Manhattan distance? Uh, Absolute of the difference of their x coordinates plus absolute of distance of their y coordinates. So for example, if I talk about 310 and 10 2, then the Manhattan distance would be 10 minus 3 absolute, which is 7, and 2 minus 10, which is minus 8, absolute will become 8. So 8 plus 7, which is 15, right? Yeah. So that is what Manhattan distance between 2 points means. Now, you want to remove exactly one point, and remaining points, whatever is the maximum Manhattan distance between any 2 points in it, that should be minimized, right? So, for example, here you had four options. Either you can remove this, or you can remove this, or this, or this. So, if you remove 310, then you have these three as remaining points. So out of these three, the two that have the maximum Manhattan distance between them are 5, 15 and 10 2. So if you calculate the Manhattan distance, it becomes 18. Second option, you can remove 5, 15. If you remove 5, 15, we are left with 3, 10, 10 2 and 4, 4. So out of these three, again, if you calculate the Manhattan distance maximum, it is 3, 10 and 10 2, which is 15. Similarly, you try to remove 10 2 and you will get 12 as the answer. You remove 4, 4, you again get 18 as the answer. So out of these four options, the best is to remove 10 2 so that we can get the minimum value of 12. So our remaining elements, find the maximum Manhattan distance of them and find the minimum out of all these values. Okay, that is what the question talks about. Cool. So I would advise here, just pause the video and come up with a brute force. I think brute force should still be easy to come up with. Okay. So if I talk about the brute force idea of this particular problem, what we can try doing is we can try to remove one element at a time. So let's say I'll go remove equal to 0 to n minus 1. So let's try to remove one by one each of the elements and see what is the Manhattan distance that we can get. So what I'll do, I'll create another array, new points, and I'll copy all the elements of the point minus the removed element, minus points of rem. Okay, so I'll run a loop on my points array, copy all of them except rem. So I'll skip rem and copy all of the remaining ones into new points. So now I have the new points. I can calculate the Manhattan distance between each of them by running two loops and find the maximum. So now run two loops for I equal to 0 to new points dot size minus 1, and for j equal to I plus 1 to again this. Calculate the Manhattan distance. So how will the Manhattan distance look like? It will look like new points of I0 minus new points of j0 absolute plus, similarly subtract the first coordinate. So new points of I1 and new points of j1. So yeah, basically find the difference between x coordinates, find the difference between y coordinates, and this is the Manhattan distance that you get, and you have to maximize it. So I'll say int max distance equal to 0 as of now. So I'll update max distance as maximum of max distance comma this. Okay, So I'll run two loops and find the maximum distance. And then if I talk about answer, then we need to minimize the answer amongst all the removals. So I'll say maximum answer is int max as of now. So I would say update the answer as minimum of answer comma max distance. So whatever the maximum distance is, we need to minimize that amongst all the removals. So if I talk about the time complexity of this, then you'll see that I'm in fact doing O of n for removing each of the elements and n square to iterate on all the elements and find the distances between them. So actual time complexity is n cube. Okay. So that is what the brute force is all about. You can try implementing it. You'll get TLE obviously, but still it would be a good implementation exercise. Let's think about how to optimize it. So for optimization, what I will do is I would look at the equation at hand that is helping us find the maximum distance and somehow try to reduce this n square. That okay, I would not have to do and calculate distance between each point, but only a few relevant points which can become farthest. So yeah, I'll use some math there. So let's try to figure that out. So x1 minus x2 plus y1 minus y2. Okay, this is what the equation looks like. So if we try to remove these absolute values, let's see what we will get. So there could be four ways in which we can remove these values, remove these mods. One could be where the values are exactly like they are right now. So x1 minus x2, where x1 is in fact greater than x2, plus y1 minus y2, where again y1 is greater than y2, right? So here if you think about it, it becomes x1 plus y1 minus x2 plus y2, right? Sum of x and y coordinates of first point minus sum of x and y coordinate of the second point. So if you try to give more concentration here, in a way, this distance would be maximum when sum of the coordinates, whoever have sum of the coordinate as maximum, I would take that as 1, and whoever have the sum of coordinates as minimum, I'll take that as the other point. So this equation would become maximum when I take point with maximum sum of coordinates minus point with minimum sum of coordinates, right? Okay, let's also try to do a similar fashion in opposite. So let's say if x2 is greater than x1 and y2 is also greater than y1, so then I will get x2 minus x1 plus y2 minus y1. This again comes out to x2 plus y2 minus x1 plus y1 and goes into the same equation, same as above, right? So again, we have to find the 2 points which have maximum sum and minimum sum of their coordinates. But there are two more ways to open these brackets. Another way could be when x1 is greater than x2, but y1 is smaller than y2. So in this case, I would go into, let me move this down so that we can see the entire thing. So x1 is greater than x2. So I'll get x1 minus x2 plus y2 is greater than y1. So this would be opposite, y2 minus y1. So in this case, I will get x1 minus y1 plus x2 minus y2 minus x2. This is what we would get. So we have x1 minus y1, or let me say minus x2 minus y2. Okay, right? So again, the same idea. We would need to find the maximum difference point. So point where maximum difference between x and y minus point where there is minimum difference between x and y. Point with minimum x minus y and point with maximum x minus y, that will give the maximum value here. Last also, when x2 is greater than x1, so I'll get x2 minus x1 plus here y1 is greater than y2. So I've opened the fourth possibility. So here again, if you see, I'll get x2 minus y2 minus x1 minus y1. Okay, just to repeat, our Manhattan distance was this. Okay, and we want to maximize this. We don't want to loop over all the points and calculate this, right? We want to find those points which can actually give us the maximum Manhattan distance. So we tried to do some maths with this Manhattan distance formula, and we tried to open and remove these mods so that we can do quick calculations. So there are two ways to open each of the mods, one with the plus sign, another with the minus sign. So first I open both with plus plus sign. So this is for plus plus. And if I resolve the equation, I got that, okay, I need to find that point which has maximum sum of their coordinates and that point which has minimum sum of their coordinates and take the difference. Second, I opened it with plus and minus and minus. So x2 minus x1 and y2 minus y1. Here also I saw that, okay, just that again we need to look at the sums only, right? Sum, maximum sum and minimum sum. Next I opened it with plus comma minus. But okay, this I'll open with plus, this I'll open with the negative sign. So y2 minus y1. So here I got the difference that, okay, first point's difference of the coordinates should be maximum and second point's difference of the coordinates should be minimum. And lastly this, where I again said it's the opposite, right? So in a way, there are just two cases that we need to look at. Manhattan distance can become maximum with first scenario where we take the point with maximum sum and subtract the point with minimum sum. Second scenario, point where the maximum difference is there minus the point where minimum difference is there between the coordinates. So just these two cases you need to look at. In fact, you can look at this case also. Let's find the coordinate with maximum sum. So if I talk about maximum sum, we'll get it at, I think 15 plus 520, right? 15 plus 520. Minimum sum, if I talk about it, I'll get 4 plus 4, 8. So one possibility was 5, 15 and 4, 4. Second possibility is when we talk about differences. So 3 minus 10 is minus 7. This is minus 10. This is 8. So minus 10 and 8. These two should give you the maximum distance, as you can see here also. If you don't remove any elements also, this is the one that is giving maximum distance, right? Cool. So basically we have reduced our calculation to find the maximum distance. Instead of it being n square, we can just run loops on this, find the one with maximum difference, minimum difference, maximum sum, minimum sum, and just do those two calculations, right? So actually, if you think about it, we can reduce this two loops to 4 for loops, maximum sum, minimum sum, maximum difference, minimum difference, which are just on. Loop, find the sum, take the max, find the sum, take the max, right? So just one loop. And then your answer would be either you do max sum minus min sum, actual distance between that. I'm just writing minus for the sake of simplicity. It's not actually minus, it will actually be Manhattan distance. Oh, actually it will be minus, right? Maximum sum minus minimum sum is what we get as answer also, right? So yeah, I think we can use minus directly. So maximum sum minus minimum sum, or maximum difference minus minimum difference, right? So yeah, just take these two scenarios and we will be good to go. Okay, cool. And out of these two I need to take maximum, so maximum out of these two. And yeah, so yeah, maximum out of either difference or the sum case. And since we want to minimize the answer, we go for minimum here, right? Cool. So with this, we can reduce our time complexity to, we decide the point to remove, and then for the remaining points, we'll simply calculate the answers, right? So the complexity actually reduces to n into n now, and it becomes n square. N square is still not enough, right? But just like we decided that we can calculate the maximum Manhattan distance by just looking at 4 points, we can in fact try to remove only those 4 points as well. Why? Right now, let's say the Manhattan distance maximum is 20, and that is because of some point A and B. So unless you remove A or B, the answer will remain 20, right? Right now, out for all the points, if the maximum distance is 20, and that is because of some points A and B. So even if you remove other points, these A and B would be intact and our answer will remain this 20. So you have to actually look at just two, removing A and removing B, and that is it, right? So what you can in fact do, instead of running this loop also, you can first calculate the 4 points with maximum sum, maximum difference, minimum difference, and just run a loop on those 4 points for remainder for to be removed equal to 0 to 3, just these 4 points, and then you try to remove them and calculate the result for them. So actually this extra n would also reduce to 4 into n, and the complexity will become n. So to summarize, first point, find the 4 points that should be removed, which are the one having maximum sum, maximum difference, minimum difference. Try to remove each of them one by one, right? So remove maximum sum point first, and then try to again find the maximum sum, maximum difference, minimum difference, find the result and calculate the answer. Then try to remove the next point, then try to remove next, then try to remove next. So 4 options, and for each of the options, we'll calculate the answer. Okay. If you talk about code as well for this, I have written a little lengthy code. So I've written 4 for loops first. I've made them top left, top right. Ideally, it should not be top left, top right. I initially started with a top left, top right, that kind of an approach. But slowly doing this maths, I was able to reduce it to maximum sum, minimum sum. So better naming would be to look for maximum sum, minimum sum, right? So what I've done, I've tried to see if whatever answer we have as of now, that point's sum is less than the new point that we are getting. So I'm replacing the answer with the new point. So this will give me the maximum sum. Similarly, here I'm finding the maximum difference, as you can see. Last, I'm finding the, like I've multiplied a -1 here. So in a way, finding the minimum sum. And in this also, finding the minimum difference. So yeah, these are the 4 for loops to get me the indices of 4 points that are right now at the end. Okay. Let's go to our actual minimum distance function. So what I do, I say find these 4 farthest points and give me the result. So if I look at the find farthest point also, find farthest point does nothing. It creates a simple vector and pushes the top left, top right, bottom left, bottom right. Actually, maximum sum, maximum difference, minimum difference, all the 4 points, and returns that vector to us. So now I know which 4 points I have to try to remove. So what I've done, I have iterated on these 4 points and tried to find the distance, right? So it is now the removed point. This is the point that I'm trying to remove. So I'll try to find the distance of the remaining points except this it. So I have called this function find distance, which says this is the list of points and this is the point that I don't need to consider. So remove this and find the answer for the remaining. Okay, and I've done distances dot push back the result for that. Let's look at find distance. So I have find distance points and the when that is removed. So first I calculate the remaining points which have not been removed as of now. So I run loop. If the index is same as the removed one, just do continue. Otherwise, push them into this new points, the points under consideration or the taken points. So once we have the points that we need to consider, again what I do, I find the farthest points in this new array. So again the four farthest points, and what I'm doing is for each of these 4 points, again finding the maximum distance from them. So actually, if you think about it, this will give me the result. Yeah. So basically, after I push all these distances into the new array, after removing these 4 points, I sort it and get the minimum one. If you don't want to sort, you can just run a loop and find the minimum one. That should be also well enough. Or if you want, you can declare an answer as minimum and then keep on updating that answer. That will also work perfectly well. Cool then. So that was about this fourth problem and how to reduce it to O of n. If you enjoyed the explanation, make sure that you hit the like button and make sure to subscribe to the channel if you are new here. Let's see you next week where we take up the next week's contest. I'm on a little bit of a break during this week because of a few engagements that I have as of now going on in my personal life. And yeah, but I'll be soon back to normal in posting almost regular everyday videos. So yeah, just stay tuned to the channel and see you guys in the next one. Bye bye.